This tutorial is going to go over how to extract and 3D print patient anatomy from DICOM files using free open source software, primarily 3D Slicer, as well as Meshmixer and Cura for the 3D printer file preparation. The first step is going to be to open 3D Slicer, and you're going to need to load the DICOM data. First, you'll import it if you've never opened it up in 3D Slicer. In this example, I am using a patient's DICOM file, so I've actually covered their private information with that white box, but otherwise your screen should look pretty similar to mine. After that loads, you'll choose your DICOM series of interest and load it. If you're segmenting bone, selecting the bone window is the best option. But for the rest of this tutorial, I'm going to use an NRRD file, which contains de-identified information. So again, you'll open up 3D Slicer, go to that NRRD file, and then load it. And the default view is going to have these 4 windows. Your first step is going to be to open the volume rendering module, and we'll use this module to first visualize a rough segmentation of the anatomy. For this video, I'm going to be extracting the patient's hip and femur on the right side. And so getting a rough view of what we're working with is really nice because it'll help us to crop down the DICOM image to just the pertinent areas. So here you can see that I am using the mouse to kind of zoom in, zoom out, rotate around the anatomy, and that's going to allow me to better get an idea of where to move these little spheres so that I can crop down the volume. If you're unfamiliar with how to use 3D Slicer, you can rotate by left-clicking and dragging. You can zoom in and out by scrolling that middle wheel on your mouse. And you can pan by holding Shift and left-clicking and dragging. But there are many good tutorials out there that'll teach you kind of how to use the basics of 3D Slicer. This tutorial is more aimed at the actual segmentation process of specific anatomy. Anyway, once you get your ROI down to the area that you want, you'll go into the crop module and then turn on voxel-based cropping and then crop it. You can then go back to the volume rendering module and turn off the ROI so that you don't see it the rest of the time, because sometimes you can accidentally click it. Up next, you'll open the editor module, go to the threshold paint tool, and you can choose whichever color you want. You don't have to use the anatomical region that you'll or label that you'll actually be segmenting, but it can be nice. You'll find a value that works for whatever structure you're segmenting. I've done a lot of segmentation of bony structures, and I've found that 210 is a pretty good value to use for the minimum threshold value, and then just the maximum value for the upper range of the bone. And the thing is, if you go too low with that, you'll include a lot of structures that are not bone, and if you go too high, you'll be missing a lot of bone. So 210 is a pretty good starting ground for the value. Up next, it can be good to link the 3 windows and then to go into the outline mode. I've just found that this way of viewing the segmentation allows you to kind of better see what exactly is included and not included in the label map. It can be good to kind of scroll through each of the views to double check that the anatomy that you want to be extracted is included in the label, and that which you don't want included is not accidentally labeled. For this next step, I'm going into the paint brush tool and using threshold paint. And the reason I'm doing that is so that I can start to separate the 2 bony structures. So at this point, all of the bone is labeled as this brown right hip label, which is nice, but then it means that when we go to print these two models or view them in a 3D viewer or something like that, the computer will see them as the same model because they're labeled as the same thing. And there's little connections between that femur and the acetabulum that will make it so that you can't really separate them easily with the 3D printer. So it's good to go through like this and manually segment out two anatomical structures that are really close to each other. As you'll see in a little bit, once we get away from where the acetabulum's just millimeters away from the femur, it'll become a much quicker process. But for right now, we want to make sure that we accurately do this. And we're using the same values that we used for the segmentation of the hip in the first place. So it should be just relabeling that brown label that exists now as blue. And I've sped up the process here because you can still see what's happening, but there's no need to watch it in real time. As we go through, we can make the circle a little bit bigger, just so it's a little bit faster, and it just almost perfectly lines up with the shape of the femur. And you might notice that some of the femur is not being included, but don't worry, we'll go back through one more time and correct that. And I know that this tutorial is showing you how to segment a femur and hip, but the same process can be applied for any other anatomical structures that you're interested in. For example, maybe a mandible, and you'd segment out the very superior portion of it away from the skull in the exact same manner. So here, once we get more toward the shaft of the femur, or the femoral neck, we can start to change into the sphere mode. And what that does is it is actually labeling, if you can imagine, a sphere of data with the same exact label map. And it's really nice because it obviously can segment through many different slices at once, but you have to be very careful using this tool that you haven't accidentally labeled structures that you don't want included with the femur. So, for example, if I move that sphere a little too far to the right, I might clip the very bottom part of the hip. And so it's important, as you're using the sphere, to check through the other slices to make sure that that sort of mistake hasn't occurred. So now I'm going to go through one last time and make sure that I get all of the femur. So I've lowered the bottom threshold value to include structures that are down to a value of 0, which again is something that I've just found from my work to be a relatively good value to use. For different structures, you'll use different values. And even for different patients, perhaps, who have denser bones or less dense bones, or perhaps not even bone if you're segmenting out muscle or soft tissue. As you can see, there's a lot of structures that are not labeled on the very innermost portion of the bone, so kind of the inner portion of the bone, and that won't really cause a problem with 3D printing or being able to use the model to view the patient's anatomy on the surface, at least. But you'll see that there are portions where the label map doesn't extend all the way to the surface, and you'll want to touch that up a bit, because then the outside portion of the model may potentially have holes in it that goes down into the middle, and you'll lose some of the information that that you could have by having a complete kind of manifold model of the patient's anatomy. So I think it's good to really make sure that you have clean margins just around the very outside of the model, but you don't have to worry too much about the inside. Obviously, it would be a better model and even print a little bit quicker if you don't have really complex anatomy like that on the very inside of the bone. However, it also takes a lot more time to segment out, so it's kind of balancing the two. So now we're going to actually create models of these two label maps now that we've kind of scanned through and made sure that we really like them. So you'll click down in the per structure volumes, click split merge volume, and then merge and build. And now my computer's kind of loading it. This process takes a few seconds, so just give your computer time, but then you'll see in that 3D view in the top right corner, eventually the labels that are now models will pop up. We can do kind of a preliminary rough estimation of whether or not the anatomy was accurately segmented by checking out that 3D rendering. However, we will clean up those models in Meshmixer in a second. So we'll save those two segmentations, the VTK files that are typically at the bottom, but instead we want to make sure that we save them as STLs, and then we'll change the directory. So we'll save them just for this purpose onto the desktop, but it's pretty good to keep all of the same patient's anatomy organized in one folder for that patient. This saving process can also take a second, so again, give your computer a little bit of time to load, and then go ahead and open up Meshmixer next. It can also be good to save the remainder of those files in Slicer, just so you can go back and edit your labels if you ever need to, but I didn't for this tutorial just because it takes up a little extra room on my computer. So once you drag and drop the model into Meshmixer, you'll let it load for a second. And the first step for what we'll do is to clean up all that noise. All those red dots that you see are points that were included in the label map but clearly aren't part of the hip. So that's kind of that noise to patient anatomy ratio that we were balancing with choosing the right threshold value. So you'll select the hip, expand to all, invert it, and then discard any of those other points that aren't directly touching the anatomical structure of interest. You'll then again select part of the hip, expand to connected, and then use the smooth tool from the deform, and it's shape preserving, so it actually keeps the shape of the anatomy really well. It just kind of helps to smooth down the surface. Next, if you want, you are able to slice off portions of the anatomy. So for example, I'm only interested mainly in the acetabulum, so I can kind of slice off that superior portion of the hip as well as that part of the spine, because it's not really needed for printing. So you can kind of move that plane around as you see fit, and once you find a good spot for it, just go ahead and hit accept, and it should close that open surface. Make sure it does, but it normally does a pretty good job. Next, once the model is more or less finalized, we'll go into the inspector under analysis, and what this is doing is fixing any sort of defects that the model may have. Doing this really helps to make the file more 3D printable. You'll see that at the end of this, unfortunately, Meshmixer isn't able to fix quite all of them, but having it come down from hundreds to just a few dozen really helps Cura to better process the file. So you can take one final look, make sure that you're pretty happy with the way the model looks, because this will be the file that will be 3D printed. Looks pretty good. So once we're happy with that, then we can export the final STL. Meshmixer is actually quite a great tool for editing STL files. The tools that I've showed you are the 3 or 4 that I find are the most useful for finalizing models for 3D printing. But I encourage you to look around and use all the other tools if there's something else that you want to do in terms of editing the anatomical models that you're producing. So our final step, you open Cura or whatever slicer program you use for your 3D printer. Our institution uses Ultimaker machines. That means that we use Cura primarily for slicing. Most programs, though, you just kind of drag and drop that final model, and then you'll want to make sure that it's positioned correctly on the build plate. In order to do that, You can use any sort of translate, rotate tools that you have. It's really good. Really nice tool that Cura has is this lay flat tool. And that's going to allow you to make sure that the model's really nice and flush with the build plate so that it prints successfully. Otherwise, everything looks pretty good. Won't change any of those print settings, so you can just slice the model, prepare the print, and then go ahead and get printing.